This is the intermediate set of the steps to inquiry posters, which are used for developing the question that's going to be testable or used in our investigations. You'll notice that if you look at the bottom of each poster down here, you'll see that there are some words: beginning, exploring, emerging, competent, and proficient. Now, as you recall, in the framework poster for Smarter Science, that was on the right-hand side and showed the progression of skill levels for students that are going through the Smarter Science framework itself. Now, the first set of posters actually cover beginning, exploring, and emerging. And so those are for people that are being introduced to Smarter Science for the first time. Once they become adept at it, then you can move to a little more sophisticated language. What you can do now is use these middle set of posters, which cover the exploring, emerging, and competent phase of skill level. And that's what this set of posters will show. What we're showing is just the first column in the framework poster, which is green. And if you'll notice, you'll see at the top of each poster, the titles are in green also. We also have sets of posters that are yellow, orange, and red for the remaining columns in the poster. So what I'd like you to do is that you start with your class and say essentially that we'd like you to measure out a substance. And they will measure a substance out using something like a triple beam balance or a very sensitive scale, and measure out this white powder that you give to them. We're calling it, in this case, mystery powder. And at the same time, you say, we'd like to also measure out a certain number of milliliters of water. What you're trying to do is build the skill levels that they need for manipulating instruments and manipulating materials that are being used in a science classroom. In this case, graduated cylinders and balances, for example. So they have to go ahead and measure out exactly the amount that you specify of each of these two substances. Then what you want them to do at this point is observe very, very well. Before you do anything, you want to have them observe very well what they see inside of here. So what you can do is have them collect information at this point. So they're looking in the white substance and they see things like, well, the fact that it's white. And you have them collect that on the first poster. But keep in mind that students have 8.5 by 11 copies of these on their desk too. So they're going to be copying what you put on the board on these posters that are hanging up. They're copying the same thing down. So they'll say things like white, granular. Some may say crystalline, and you have them look again and notice that it's not really crystalline, this substance. And they'll say things like it's light, for example. They'll get all sorts of observations like that. So you have them focus on the white powder, and then what you do is say, at this point, I'd like you to pour rapidly the clear liquid in one container into the white powder in the other container, and watch what happens. Observe very carefully, because you're going to be writing down those observations too. And at this point, they can also take a look at this. What usually happens with students is that they start touching it immediately after you've said it's okay for them to touch it. They start touching it and looking at it very carefully. The one thing you have to be very careful with this, as a side note, is that because of the fact that it absorbs water so greatly, they have to keep the initial powder away from any orifices in their, like their nose or their eyes or anything like that, because it will absorb all the water from that. So that's a safety note. But once they've got this, then you say, now make some more observations from what you see. So at this point, they can write more observations down right now. So quite often what you do is you also give them a magnifying glass so they can look really, really closely at this too. So at this point, they will see things like the fact that each of these particles that are in here are a zigzag in shape. So they look like an opened accordion. They can put that in too. And they can say the volume is much, much larger. So they can talk about the change in volume. And you're collecting all of these things, the before and after observations. Then you say, okay, it's time for homework at this point. So this is towards the end of the class, and you say to them, I'd like you to go home, and I'd like you to find out for me the difference between physical and chemical change. That's your homework. The difference between physical and chemical change. And we'll discuss it tomorrow. One of the things that students can also do, besides observing by writing down on a piece of post-it paper, is also draw diagrams of what they see. What you find is that a lot of students, especially boys, are much better at being able to see with observations through drawing and making diagrams. So for example, you might encourage them to use the bottom part of this poster and actually really close up observe the particles that they see, and they may see something, you know, looks like this type of structure. So they'll see that zigzag shape that they find in the actual granules, and the fact that these granules form into regular surfaces like that. And what you can encourage them to do is actually label that too. So they may actually put labels on it saying that they see this zigzag accordion type shape. So that's one thing that you should also encourage. Now, going on to the next step, once the kids have returned the next day and they've actually looked up for themselves the difference between a physical and a chemical change, you can then encourage them to re-examine the materials from yesterday, because you still have them there. And at this point, because you know that it was a physical change, you can lead them towards that and say, okay, what questions do you have about that physical change? And if you encourage them well enough, you'll be able to get questions like, what happens if I change the amount of white powder that I use? So you might be talking about the amount of white powder. Or they may say, what happens if I change the amount of water that I use? Will it increase or decrease the volume of snow that was developed? They might ask other types of questions, things like, what happens if I change the temperature of the water that I use? So we use colder water or warmer water, and so on. So you can encourage a lot of questions, and you can record them on poster 1, and they can copy this down into their own 8.5 by 11 sheet that they have in their notebook. The nice thing about the fact that they're copying this down is that they can then use this as an exemplar when they're doing other experiments and other investigations in the future. One of the things you have to think about is the fact that scientists observe very well. Observation is probably one of the most important skills when it comes to the process of doing science and science research. And what you have to do is, as a scientist, look at the observations that you've made about a particular event or phenomenon. In this case, it happens to be making instant snow. And if you look at all these observations, you then focus in on one of the observations and say, I want to study that. So in this particular case, with instant snow, what we're going to do is take a look at volume. And we're going to watch how the volume changes as we alter different kinds of variables. And the variables are all of the questions that we had here. So what happens to volume, for example, if we change the temperature of the liquid that we pour into the powder in the first place? What happens to the volume when we change the water, the amount of water that we use? Or you might want to look at what happens when you change the amount of instant snow that you use, the powder itself. These are all different kinds of things that you can do to change the volume. What we're going to do in the next step is choose one of these three, and students will have many, many more, I can guarantee you that. What they do is they choose one, and then they develop their testable question from that. Now let's move on from poster 2 to poster 3. In poster 2, what we've done is we've identified that we want to look at the volume and how the volume changes. And we've identified a number of variables, in this case only 3, but as I said before, you could make this 6, 9, 12 different variables. And what you can do is at this point you can choose to have the entire class focus on one variable and everybody is doing the same thing. Or you can change it up a little bit and you can have groups of kids working on a single variable. So group A may work on investigating the amount of water and how that changes and affects the volume. Or you might have group B looking at the temperature of the water that's being added and how that changes the volume. And you could have group C working on what happens when you change the amount of snow. So you could have 5 or 6 different groups in your class, all doing something different, but all related to one concept. In the third poster, step 3A, what will I change? Let's suppose that we're talking about group B, and group B is looking at temperature alone. That's the variable that they will change. That becomes their independent variable, something that they can manipulate. They will be looking at, I will measure or observe this result. That's the dependent variable. They will be looking at the change in volume. So, step 3A, what will I change? I will change temperature of the water to see what effect it has on the volume of snow that I produce at the end. What happens to these other ones? These other ones, step 3B, what will I not change? That particular group will not change the amount of water that they use or the amount of snow that they use. All they will be changing is the temperature. And if there were 6, 9, 12 other variables, they all go down here. They become control variables. Now we're ready to move on to the fourth poster in the series. The fourth poster actually establishes the investigation question that you want the kids to go through. So at this point, what you can do is look at poster 3 and say, okay, at this point, what I'm looking at is what will I change and what will I measure? What you can do now is go over to poster 4 to step 4 and say, what is the question I want to explore? What we do here is very rigidly and very helpfully, I hope, allow you to develop a question by just dropping in these post-it notes from one poster to the next. So if I change the temperature of the water that I'm using to make instant snow, what will happen to the volume? So what we've done is we've created a very formatted way for them to develop a question. This is useful when you first introduce this type of concept to students. Afterwards, what you find is the students become very comfortable with it and they can actually do this themselves without having these prompts in front of them. They know that they have to make an if-then statement for their hypothesis. And what we do is we encourage more of this by also introducing a close exercise at this point. So again, we're looking at a bit of literacy here. And we have the students fill this in. So what is my prediction, what and why? Based upon my question, I predict that if the temperature is increased or decreased, let's say increased, then the volume, this one, will increase or decrease. And at this point, my prediction is that it will increase. Second line here says, how will the dependent variable be affected? And maybe students at this point will want to be able to put in more description about how they think it will be affected. Finally, down here in the why section, this becomes the rationale for why they think that will happen. So I think this will happen because if you add, well, it could be anything. If you add hot to things, quite often they expand. And maybe that's their reason. So at this point, they can put all that in. And This is the type of thing that really cannot be marked. It's more a case of you're checking for their conceptions or their misconceptions so that you can help assess and evaluate them as they move forward in their investigation. But this is good in terms of understanding their reasoning behind their prediction and their hypothesis. Now you can go on from here, help them to develop data tables so that they can collect data as they go forward through their investigation. And the data tables may be in the forms of a very simple table or a chart, or they may be collecting materials to make a graph eventually, which is in the third column. We'll talk about that later.